Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The second element we're going to discuss here is a capacitor. And we know that capacitor is a passive element, and current entering a capacitor will have a positive polarity, and current leaving a capacitor will have a negative polarity. And if we relate this current and voltage of this capacitor, we know that we have a current equal to C dV dt, and we know that this is in time domain. And if we write in terms of frequency domain or in phasor form, we will have a current Ej omega t plus theta I equal to C d dt Vm, this is a magnitude, and E j omega t plus theta V. Okay, and then if we want to, as we know that this is a time domain, still in time domain, even though we write it in phasor form. So if we want to leave the time domain and enter a frequency domain, we can do a differentiation and divide by E j omega t, so that we reduce a t there. Okay, we will get Im E j theta I, which is equal to j omega c Vm E j theta V. This is using differentiation and division. Divide by E j omega t, we will have this. And we know that in phasor form, polar form, we have a Im theta I, or Im exponential form j theta I, same as voltage, Vm theta V or Vm Eg theta V. And if we write this in terms of polar form, this is I, which is equal to j omega c V, is a form. And if we write this in terms of impedance of capacitor, we will have a voltage divided by current, which is equal to 1 over j omega c. And if we want to reduce j here, not reduce, just move it on top of this, so we will have a negative j square over j omega c, and this we can cancel out, so we will have a negative j over omega c, and this is actually equal to some real part. In this case, we have a 0 real part minus j 1 over omega c. And if we draw this in terms of complex plane, this is a real, this is a imaginary, and down here is actually negative 1 over omega c, and this is a negative j side. Okay, let's move this here. Okay, now how to write this in terms of the phase? If you look at here, this is 270 degree, and if you draw here, this is negative 90 degree. So we can say that this is also equal to 1 over omega c with 270 degree, or 1 over omega c with negative 90 degree. Okay, now how to write down, how to relate this with the theta difference. And this is actually equal to theta v divided by Im theta I, which is equal to 1 over omega c. Say we take the negative 90 degree because this is smaller in degree. So this part, we know that theta v minus theta I, because of the division there, and this is equal to negative 90 degree. Oops. Then how to draw a complex plane that relates this phase difference? We know that theta I is actually equal to theta I equal to theta v plus 90 degree. And if we draw this on complex plane, maybe this is the v with some theta v, and theta I is equal to theta v plus 90 degree. So we can add up here 90 degree, and this is the current, phasor current. Okay, so we can say that I, current, is leading voltage by 90 degree. Okay, that's all for this